Hi, my name is Garrett Goodwin. This is my Geography 356 mapping project. Today I'm going to be looking at alternative energy use and CO2 emissions in Europe. So the objective of this project is to look at two variables and map them across Europe. The easiest way to do this is to calculate the location quotient, which is just a ratio of the quantitative value for a defined area to the specific norm. The equation is LQ equals SI over A. And really, in terms of this project, S sub I is just the data from a specific country, and A is the norm of Europe as a whole. So for this, I was able to obtain good data for 44 countries from World Bank. Alternative and nuclear energy use came as a percentage of total energy use. So in order to find the location quotient, I had to divide this by the average alternative and nuclear energy use of Europe. CO2 emissions were given as metric tons per capita. So this was already divided among the population. So all I had to do was, again, divide this data by the average for Europe. I then used mapchart.net to generate the graduated color maps of Europe. And I expect to see CO2 emissions decrease as alternative energy use increases. And the main reason for this, as shown on the chart on the right, majority of CO2 emissions come from producing electricity, mostly through burning of fossil fuels. So obviously, the more energy you can produce from wind and solar and nuclear, the less CO2 emissions you're going to be giving off burning coal and other fossil fuels. So this is my first map of nuclear and alternative energy use. Definitely several countries that stand out: Iceland, Sweden, Norway, France, Switzerland. The map doesn't really show how much Iceland stands out. If you look at the data specifically, its location quotient was 6.05, and they have about 90% of their total energy is alternative energy. And just for comparison, France is second behind them, and they only have 47% of their energy is from alternative. So again, Sweden, Switzerland, Germany also has a fair amount of alternative energy. This is really kind of set forth by the EU, a big initiative to sort of increase this and reach a 20% goal by 2020 for the EU. They have actually already reached this in the last couple of years, but they're looking to keep pushing beyond kind of what they expected. And this chart below shows sort of the different types of alternative energy and how they've grown and been used over time. So obviously hydropower has sort of been the mainstay for the longest, but in recent years wind power and solar power have started to make a significant impact. Here is my map for CO2 emissions. Definitely see a lot of emissions in Central Europe. There's a lot of population density in that area, a lot of population pressure, and the land has just really been optimized and used for many years compared to some of the other countries. Sort of a lower location quotient for many of the Eastern European countries, Ukraine, Belarus, countries in that area. A lot of the emissions dropped after the Soviet Union fell because a lot of the heavy industries sort of died off after that. So that was sort of a kind of a benefit of that all happening. Cleaned up kind of the emissions significantly. So again, this whole initiative that the EU has put forth, again with the 20% alternative energy use, it's also 20% cut in greenhouse emissions since 1990, and a 20% increase in energy efficiency, which is primarily geared towards housing, industries, factories, and things like that, and especially transportation as well. The EU has what they call the emission trading scheme, where countries are given sort of allowances on how much they can pollute, and they're given a certain time period when they sort of have to make and meet those requirements, and they get to a point where if they're well below what they're allowed, they can actually sell off a certain amount of allowance, if you will, towards other countries that are exceeding. So it kind of opened up this whole economic trading scheme where countries can kind of use each other and balance the emissions. So my conclusion really wasn't a very big correlation. I expected to see, a bigger difference. You can see my graph below. It's nearly flat trend line. The data is really pretty spread out. So I expect the correlation to increase by 2020 as these goals sort of get met by more and more countries, and the goal kind of continues to progress onto 2030 and even more onto 2050. So it'd be interesting to see kind of how this changes over the next 10 to 15 years. So that concludes my mapping project. Thank you for watching.